Hello friends, welcome to our channel Knowledge Amplifier. So in this particular video, I am going to discuss some concepts related to statistics. Okay, these are fundamental concepts and these will be helpful in our machine learning and data science course also. Okay, so first thing is random variable and random event and probability distribution. These are the major topics of our today's discussion. I hope you have already studied these particular topics in your class 12 mathematics course, right, in school. Okay, so just a quick recap I am giving. So random experiment is what? Random experiment is such experiment which if you conduct again and again in the same manner, you might get different result. Like if you throw or toss with one unbiased coin, then either head or tail will come. This you know, right? But as soon as you toss, you cannot say whether head will come or tail will come. At this instant head is coming, same way with same force you have tossed the coin again, next time you might get tail also or head also. Okay, like that rolling dice. Okay, you might get 1 2 3 4 5 6, any possible combination, any possible value, right? So these are called random events. Okay, and sure event is what? That sun will rise in the morning. Okay, right? Then suppose I am setting one microwave for making some food. Okay, then it is sure that the microwave is going to work properly. So these are kind of sure event. If you study properly and question comes like how you studied, then you will be scoring good marks if you write properly. So like this, so sure event means the outcome is known, right? And random event means that if you conduct the same way, then also experiments might have different values. Okay, and what is random variable then? Random variable are basically the values which are basically outcome for random experiment. Okay, that's all, simple, right? Like for example, when you are tossing a coin, head or tail, okay, random variable. Then like if you are rolling a dice, then 1 2 3 4 5 6, any value you can get. Okay, these are set of values. This set of values for a random experiment is called random variable. Okay, now here I am just going to discuss with respect to mathematical point of view. Okay, so you are given this kind of table, suppose, where x, as soon as if you get this kind of table, then you should understand x is our random variable. Okay, which is basically a set of values for any random experiment. Okay, suppose 0.2 can be outcome, 0.4 can be outcome, 0.5 can be outcome, 0.8 can be outcome, and 1 can be outcome. Okay, so for any random experiment, we can't say that what value will come at the next time when we will be doing the experiment, but we can say what is the probability, right? Like if you toss a coin, then the probability that head will appear is half, probability that tail will appear is half if the coin is unbiased. If you roll a dice, then 1 2 3 4 5 6, among these 6 values at least 1 will come, so for each probability is 1 by 6, like that. Okay, now suppose there is one particular random event for which, or random experiment for which the possible outcomes or set of values are 0.2, 0.4, 0.5, 0.8 and 1. Okay, and the corresponding probability we have 0.1, 0.2, 0.2, 0.3 and 0.2 and 0. Okay, this 0 is for otherwise. Okay, that is any value apart from this 0.2, 0.4, 0.5, 0.8 and 1 is not possible as outcome for this particular random experiment. Okay, so for otherwise we are getting 0 probability, that is this particular case will not at all appear in our experiment, right? So this kind of tables we will be getting. So the first one, the x, which is basically set of values for our random experiment, is called random variable and the corresponding probability is given. This is called probability distribution, we can say. Okay, and this particular thing is called probability mass function. Okay, so basically what is the probability that 0.2 will come, that is 0.1? What is the probability that 0.4 will come, that is 0.2? What is the probability that 0.5 will come, 0.2, and so on. So if you put all the possible random variable values in the x-axis and in the y-axis, if you plot this probability value, then whatever graph we will be getting, that is discrete graph, obviously, because you can understand this is discrete event, so obviously it is going to be our probability mass function, right? And if we are working in continuous probability domain, that will be considered as probability density function. Okay, so first terminology which I want to discuss is Rx. What is Rx? Possible values of x, range of x, that is the set of possible values of our random experiment as outcome. What are the possible values we can get? Obviously 0.2, 0.4, 0.5, 0.8 and 1. No need to write otherwise, because otherwise is not possible, that's why probability is 0, right? Then suppose you might ask this kind of question: what is the probability that the random variable outcome, that is random experiments outcome, will be less than equal to 0.5? Okay, so very simple, less than equal to 0.5. So what are the possible outcomes which is having value less than equal to 0.5? 0.2, 0.4, 0.5. So my outcome should be within this range, 0.2, 0.4, 0.5, and this is belongs to symbol, right? So probability of x belongs to either 0.2 or 0.4 or 0.5. So we are simply adding them up. So 0.2 is appearance probability is 0.1, 0.4 appearance probability is 0.2, 0.5 appearance probability is 0.2. So 0.1 plus 0.2 plus 0.2 is 0.5. All are independent events, obviously, right? Not dependent on one another, right? So we are getting this kind of thing. Then here, probability of x, that is my outcome of the random experiment, should lie in this range, 0.25 to 0.75. So how we can do? Just find what are the values which might come in this range. Okay, so 0.2 is less than 0.5, so it will not come. 0.4 is coming in this range, in between 0.25 and 0.75, so 0.4 will appear. 0.5, yes, it will appear. 0.8, no, it is greater than 0.75, so it will not appear. So we need to just add the probability values corresponding to the 0.4 and 0.5, okay, which is basically 0.2 plus 0.2, which is 0.4. Simple, right? Like this, I hope you can calculate. Now this is one interesting question: what is the probability? This is kind of called conditional probability, that what is the probability that random experiment will take value 0.2 with this information provided that our random experiment will be taking value less than 0.6. Okay, so here is the formula, very simple: P of A intersection B is equal to P of A multiplied by P of B by A. That is, A and B, these two events will occur simultaneously. The probability is A has occurred, and the conditional probability of this one, okay, that is B will occur where we know that A has already occurred. Like this we write, like P of B by A. Okay, or we can write like this: A and B will occur simultaneously. There is another possibility that B has already occurred is known, then B is already happened. By knowing this, what is the probability that A will occur? That is P of B multiplied by P of A by B. Remembering formula is very simple. You write one variable and then write second variable at the numerator, and the variable which you have written first, that you write in the denominator. Like see here, P of A we are writing here, so A will come in the denominator, and in the numerator B will come. Similarly here in this formula, P of B is we are writing on the upper side, so B will come in the lower and A will come in the upper side. Simple to remember the formula, right? Now in this particular question, okay, what is A? A is basically x equal to 2, x equal to 0.2, and what is B? X less than 0.6. Okay, right? So we are considering this particular formula. Suppose P of A intersection B is equal to P of A multiplied by P of B by A, or this one you can consider. So see, if you consider the second formula, P of A intersection B is equal to P of B multiplied by P of A by B. So P of A by B is equal to P of A intersection B by P of B. That's what I have written here. And here A equal to event when x equal to 0.2 and B is nothing but event when x less than 0.6. Now we have to calculate this A intersection B and P of B, and we can simply divide and get the result. So A intersection B, that is x equal to 0.2, random variable outcome is 0.2 and random variable is less than 0.6, right? So simple programming from programming concept also we can say x value less than 0.6 are what values? 0.2, 0.4, 0.5, okay, and simultaneously x should be 0.2 also. So obviously x equal to 0.2 and x less than 0.6 is obviously one possibility, x equal to 0.2, right? And B is what? X less than 0.6, so that's what is written. So basically here P of A by B is nothing but P of x equal to 0.2 by P of x less than 0.6. What is the probability that a random experiment outcome will be 0.2? See, that is 0.1. So 0.1 by, what is the probability that a random variable outcome will be less than 0.6? That is, it might be 0.2, it might be 0.4, it might be 0.5, like here. Okay, so probability, corresponding probabilities are 0.1 plus 0.2 plus 0.2, 0.6. Okay, sorry, 0.5. 2 plus 2, 4 plus 1, 5. So 0.1 by 0.5 results to 0.2. Okay, so this is how you can solve the problems related to probability mass function. Probability mass function is nothing but simply we can say probability distribution for our discrete process. Okay, I hope you have understood this. This is all for this video. Thank you.